welcome back to the channel. So today in this video lecture we're going to be solving this problem: find the city with the smallest number of neighbors at a threshold distance, which is a yet another problem which can be solved using Dijkstra algorithm. So basically in this problem we are given n cities numbered from 0 to n minus 1. For instance, we have if we have 4 cities, they will be numbered from 0 to 3. Also, we are given an edges array where each element in this edges array is a tuple. First two integers represents a node which are connected by an edge, while the third integer in the tuple is the weight of that edge, and it's a bidirectional weighted edge. Also, we are given an integer distance threshold. We'll see what is the utility of this integer. So we have to return a city, the city out of all those cities numbered from 0 to n minus 1, which has smallest number of cities which are reachable through some path whose distance is at most equal to that integer distance threshold. Fine. So we have a bunch of cities numbered from 0 to n minus 1 connected by bidirectional weighted edges. We got to find a city with the smallest number of nearby cities that are at a distance of at most equal to distance threshold. If there are multiple such cities, we will return the city with the greater number. For instance, if we have two cities, city number 2 and city number 3, then we'll return like the city number 2 and city number 3 with the same number of nearby cities with the distance of at most equals to threshold distance, then we'll return city number 3 because it is greater in number. Now, what is the distance of a path connecting two cities I and j? It is equal to the sum of edge weights along that path from I to j. Okay, so let's better understand the problem statement using an example. So here we have our example. We have the city with the smallest number of we have this graph which has 4 integers, so n is 4. All of the cities are numbered from 0 to 3. Then like we can see 0, 1, 2 and 3. Also, the threshold distance for this test case is 4. So threshold distance for this test case is 4. Okay. Now let's start from city number 0 and check out the nearby cities which are at a distance of at most equals to 4. Now for city number 0, the nearby cities would be city number 1 because it is at a distance of 3 units, so 1. Also city number 2 because it is at a distance of 3 plus 1, that is 4. Also it does not exceed this 4, so it will also be there in the list. City number 3 will not be included in the nearby cities because its distance is exceeding the threshold distance. Its distance is 3 plus 1 plus 1. The minimum distance from 0 to city number 3 is 5, which exceeds this threshold distance. So these are the only cities which we can include for city number 0, which are at a distance equal to the threshold, like equal to or less than the threshold distance. Let's see the same for city number 1. For city number 1, we'll have city number 0, which is at a distance of 3 units here, this edge. City number 2, which is at a distance of 1 unit, and city number 3 as well because it is at a distance of 4 units or 2 units because we go from 1 to 2, then from 2 to 3. This is the shortest distance from city number 1 to city number 3. Let's check for city number 2. For city number 2, we will have city number 1 at a distance of 1 unit. The shortest distance from 2 to 1 is 1 unit. The shortest distance from 2 to 3 is also 1 unit. So it is also included because 1 does not exceed 4. The shortest distance from 2 to 0 will be 4. 1 plus 3, that is 4. So it will also be included. City number 0 is also there. Let's go for city number 3. For city number 3, the nearby cities which does not exceed this threshold distance would be city number 2, which is at a minimum distance of 1 unit, city number 1 which is at a minimum distance of 2 units. That's all. City 0 is not included because the minimum distance from 3 to 0 will be 5. From 3 to 2, from 2 to 1, then from 1 to 0. So these are the corresponding cities for each city of the graph. Now what will be my answer? What is the demand of the problem? The problem says give me the city with the smallest number of neighbors or nearby cities which does not exceed this integer in distance. So for 0 we have 2 cities, for 3 we have 2 cities. Okay. Now which one will be the answer, 0 or 3? They have same number of nearby cities which does not exceed this threshold distance. We'll take that integer which is greater. We'll take 3 because that's given in the problem statement. So 3 will be the answer for this test case. Okay, that's what we have to do. Now what is the approach to solve this problem? If you have followed the series from the very first video, then you would come to the conclusion that all we have to do is to just find the shortest distance from every city to all other cities. So from city number 0, find the shortest distance to all other cities. Now pick those cities out of those cities which are at most at a distance of threshold distance. So for city number 0, calculate the shortest distances. So let's calculate the distance array. So we'll use Dijkstra algorithm. We can use Dijkstra algorithm to do so. So Dijkstra algorithm calculates the distance array for each node of the graph, which represents the shortest distance from that node to all other nodes. So for city number 0, the distance array would be like, so for city number 0 we'll have 0 for itself. For city number 1 we'll have 3 units. For city number 2 we'll have 4 units, 3 plus 1 4. This is the shortest path. For city number 3 we'll have 3 plus 1 plus 1, that is 5. This will be the distance array calculated for city number 0 using Dijkstra algorithm. Now we can see that out of all these cities, I will pick city number 1 and city number 2. Why? Because these cities are at a distance which does not exceed this 4. So for city number 0, pick city number 1 and city number 2. So pick city number 1 and city number 2. So it's not 4, it's 2. Fine. So I have this type of list prepared here. Then calculate the same distance array for city number 1. So for city number 1 we'll have 0 for, so from city number 1, the shortest distance to city number 0 would be 3 units. The shortest distance to city number 2 would be 1 unit. The shortest distance to city number 3 would be 2 units. So this is the distance array for city number 1, considering it as the source city. Now for city number 1, these will be the cities 0. Now I will consider city number 0, 2 and 3 as the valid cities, because the distance to these cities does not exceed this 4. So like here. Then calculate the same distance array for city number 2. So put 0 for city number 2 because it's the source city. Now from city number 2, calculate the distance, the shortest distance to all other cities using Dijkstra algorithm. So find the shortest distance to node number 1, find shortest distance to node number 3, find shortest distance to node number 0. It would be 1 plus 3, that is 4. Now from this distance array, pick those cities which are at a distance not exceeding this 4. That would be city number 0, 1 and 3. And that's what we have here, 0, 1 and 3 for city number 2. Now calculate the distance array finally for city number 3 as well. So calculate this distance array for city number 3. So for city number 3, the distance would be 0. Now distance to all other cities would be, to city number 2 it would be 1, to city number 1 it would be 1 plus 1, that is 2, for city number 0 it would be 1 plus 1 plus 3, that is 5. So what will be the valid cities? It would be city number 1 and city number 2. Fine, because they are at a distance which is not exceeding this 4. So I will put city number 1 and 2 for city number 3. So this will be my configuration. Now out of all these, so that's how, so after calculating these distance arrays, simply pick out that city which has a minimum number of neighboring cities not exceeding this 4, and if there are multiple cities, return the city with the greater number. Like here in this case we had city number 0 and city number 3 with the minimum neighboring cities not exceeding this distance 4, then I return city number 3 because this is greater in number. So that's all we have to do. For every pick every city of this graph and consider that city as the source city. Calculate the distance array, the shortest distance array, using Dijkstra algorithm which we have learned in the previous videos. Then iterate over that distance array and pick out those cities which are at a distance of at most this threshold distance. Fine. If the number of such cities, now out of all these nodes, pick out the node with the least number of such cities. Fine, and that would be my answer. So that's all we have to do. So before moving on to my pseudocode implementation, just try to implement the solution yourself. This is a medium problem, so it would not be very hard to implement the solution if you have paid attention till now. Now let's jump to my implementation part. So this is a pseudocode for the given problem. Let's write, so we have this function find the city which takes in the number of nodes, the graph, corresponding graph, and the threshold integer. Initialize an integer city with a very large number, so it's not 0, initialize it with a very large number because we want to find minimum neighboring cities, and this integer city initialized to -1. This will store the final target city which we require. Now iterate over all the cities starting from city number 0 till city number n-1, and for each city, considering it as the source city, run the standard Dijkstra algorithm. So we know what we do in Dijkstra algorithm. We have a priority queue. We push the source node into the priority queue along with its distance. We declare a distance array of the same size equal to the number of nodes in the graph. We initialize the distance with a very large number. Initialize the source vertex with 0 because we are starting from that vertex. Run the while loop till that priority queue is not empty. Pull out the top pair, like the pairs will be sorted according to the distances in increasing order. Pull out the pair with the least distance from the source node, and from that source node just iterate over its neighbors and try to perform the relaxations. So this is the neighbor node, this is the edge weight from node to neighbor edge. Now check if there is a scope for relaxation. If there is, if we can move to the neighboring node with the lesser distance, then update the distance for the neighbor node and push that new pair into the priority queue. So continue this till the priority queue is not empty, and finally we'll have my distance array prepared at the end of this while loop. So from here just initialize an integer count which will be used to count the valid cities. Iterate over the distances array calculated from the by running the Dijkstra algorithm. Now out of all those distances, count those cities which are at a distance less than equals to the threshold distance. So we have the count of the neighboring cities. Now if the number of neighboring cities is less than the count which we already have, then simply this is a better answer, and in that case initialize the city variable with the current city and update my count variable. Fine. And finally at this point we'll have our city in this city variable which is the greatest number city with the least number of neighboring cities which are at a distance of at max threshold, and we return that city at the end of this function. Fine, that's all. So let's jump to the code implementation part. So let's code it here. So we have this class solution, we have this find the city function which takes in the number of nodes, the edges and the distance threshold. So first of all, just prepare the adjacency list from these edges. So adjacency list of pairs of n nodes, because the nodes are numbered from 0 to n minus 1. So let's call it edge. Iterate over the edges array. So we have three things in the edges array. We have tuples. So create an edge from the very first node to the second node. Push back edge 1, edge 2. Also create a now we have a bidirectional edges, so create a edge in the reverse direction as well. Edge 0, wait, edge 0, edge 2. So we have bidirectional edges. Now declare two variables, count and initialize it very large number, city with initialize it with -1. Iterate over the every city of the given graph. For every city, declare a distance array. Also declare a priority queue. So it's a min heap basically. Push the source node into this min heap with its distance. Initialize the distance for the source node to be 0. Iterate over the priority queue till it is not empty. Okay, pull out the top pair from this priority queue and check if the distance that we already have for this node. So we extract two variables, node that would be p dot second and its cost that would be p dot first. So if the distance for the node is already better than this cost, then we continue to the next pair. Otherwise, iterate over the neighbor nodes for the current node and check if there is a scope for relaxation. So distance to is better than distance to the node plus the weight that we have. If it is the case, then initialize the distance to this node to initialize the distance to the new one. Okay, so finally we'll have our distance array prepared at the end, and we're gonna return the integer. We're gonna return the now here at the end. So at the end of this while loop, we'll have our distance array prepared. So we initialize the count variable to 0, then iterate over the neighboring cities. So if less than equals to, so count all the cities which are at a distance of threshold, at most threshold distance which we are given here. So distance threshold, and count them. Check if we have a better answer. If the count is less than equals to the count, then update the count and the city as well, city to the current city. Finally, we'll have our city stored in this city variable, which will return at the end of this function. Fine. So in this fashion, we'll run the Dastra algorithm, and let's try to run this code. Okay, so let's submit it. Okay, so it's submitted. Let's just okay, let's discuss the time and space complexity for this solution. Now we know that we are running Dastra algorithm for n times because we have n cities. So the time complexity would be n into the time complexity for Dastra algorithm. That would be the time complexity. Fine. So what is the time complexity for Dijkstra algorithm? The time complexity for Dijkstra algorithm is E log n, where n represents the number of nodes and E represents the number of edges, multiplied by n. That would be the time complexity for the given solution that we have explained. So that's all for this video. If you like the video, then hit the like button and make sure to subscribe to the channel and continue in the Dijkstra algorithm series, where we'll be solving more problems of the same algorithm, even the harder problems as well. So stay tuned with me. I hope to see you all in my next video.